In this video, I'll be demonstrating an easy way to find optimal fantasy teams in games where we have a fixed budget to spend on players. I'm going to focus on the Fantasy Premier League game shown here, however the same concept applies to other games like Fantasy NFL. Let's get started. To make this work, there are a few things that we'll need. First, we need projected points and prices for all of the players. I'm going to use the projections from fantasyfootballscout.co.uk, though you can get projections from other sites as well. This is also true of other games. For example, with Fantasy NFL, you can get projections from 444.com, as well as other sites. Next, we're going to need a spreadsheet program. I'm going to use Microsoft Excel. However, the free Google Spreadsheets application will also work for what we're doing. So our first step is just to take this table of projected points and prices and copy it into a spreadsheet, which I've already done here. In fact, since the Fantasy Football Scout projections are not free, I've introduced randomness to a random adjustment to all of these numbers you see here, so they're not exactly what you'd see on the site. Looking at the columns, you can see the names of all the players, their team, their position. This spreadsheet just has the forwards on it, so it's all forward, prices, and then estimates for the minutes they'll play, goals scored, assists, clean sheets, bonus, yellow cards, and finally points. For what we're going to do, the only columns we really need aside from the name are points and price. Finally, there's a column after that called value, which we'll be talking about in depth later on. Finally, the last thing we need is some idea of how much money we want to spend on players. I'm going to follow the suggestion of one of Fantasy Premier League's best players, known as Triggerlips. On his site, he suggested the following amounts to spend on each of the positions. And his experience playing the game, if you deviate too far from these, you end up with an unbalanced team that runs into trouble later on in the season. So I've gone ahead and penciled in the suggested budget for forwards. Above that, you can see the total price of the 3 forwards on the top of this list. In Fantasy Premier League, we have to pick 3 forwards, so that's why I've added up their prices. And finally, the points for the top 3 on this list. Now, the list is currently sorted by points, so these are the top 3 scoring forwards in the game, and obviously it'd be great to have all of them on our team, but as you can see, they cost more than we want to spend. So to come up with something that's within budget, one thing we can do is use the value column. So it's intuitively clear that if we have a fixed budget and we want to get as many points as possible, the thing to do would be to compute what's called the value of each player, which is simply its points divided by its price, points per price, sort all of them by points per price, and then take the ones with the highest points per price until we run out of money. Let's see what happens when we try that. I've already computed their values, and now we can sort on that. And what you see is that the top 3 here are all very cheap forwards, and they add up to only £15.5 million. So while it is true that it would be a good solution to sort them by their value and then take them in order until we run out of money, it's typically going to take far more than 3 to run out of money, and so the top 3 by value often will come far short of the budget that we want to spend. For this reason, some people have suggested that value is useless or even mathematically unsound, but that's not true. Actually, it has a key property which will be very useful to us, and that is the following. If it were the case that the amount we wanted to spend was 15.5 rather than 29.5, then these 3 would be the optimal team to have. Okay, that's the key fact that we're going to use. We're going to generalize it and try to make it a little more useful next. So the way to generalize it, we'll introduce what I call the points adjusted value. And all of that is the points subtracting off an adjustment divided by the price. So rather than taking the points divided by the price, do the points minus the adjustment divided by the price. So let me type in that formula. And remember to put a $sign in because I'm about to drag this down and I don't want the points adjustment cell to be changed. Now with a points adjustment of 0, it's exactly the same as value. Okay, points adjusted value is just regular points minus the adjustment, but if the adjustment is 0, then it's exactly the same as regular points, and then dividing by the price gives a value. But if we change it, you'll see that now the numbers become different. And let's see what happens when we sort them. Before we do that, notice that right now, as I said, there's cheaper players at the top. All the 10+ million pound players are in the bottom half. And if I sort it on the adjusted value, largest to smallest, you'll notice that the expensive players start moving up. Furthermore, the price of the top 3 on the list has gone up from 15.5 to 17. I can change this to 75. Sort it again. And now the more expensive players move up further. The total price goes up to 19.5. Let's try 100. Now that we've got some expensive players actually in our team, the price is all the way up to 25.5. And the key point is the following. Adjusted value has exactly the same property as regular value, which is that we know that if our total budget were 25.5, then these 3 at the top would be the optimal team. Okay? So while it doesn't tell us exactly what the optimal team at 29.5 would be, it tells us what the optimal team would be at whatever the price of the 3 on the top of the list happens to be. 25.5 is fairly close to 29.5, so it's likely that this will give us some insight about the optimal team. But we don't have to stop at 100. We can go even further. Let's go up to 110. You see now we're at 28 million. That's nearly the whole budget spent. And again, it has the same property as value, which is that the top 3 here, those are the optimal forwards to take if the budget were 28 instead of 29.5. So we can keep playing like this. Let's go up one more to 111. And now you see it jumps all the way to 29.5. And that means that these 3 forwards now on the list, those indeed are the optimal set of forwards if we want to spend 29.5 million pounds, which is exactly what we wanted to spend. Now, it won't always be the case that when we increase the points adjustment that we'll exactly hit the budget we want. It may be that we have one amount that goes just below the budget, another goes above it, but we do get very useful information. We get some teams that are nearby to the budget we want to spend, and so we have the option then of maybe trying to spend a little more or a little less at a different position. Alternatively, we can take one of the teams that's nearby to the budget we want to spend, take that optimal team, and try changing in or out a few players. And that's likely to be able to lead us to a team that, if it's not optimal, it's probably very close to optimal. Finally, I wanted to quickly switch over to the defense for a second and show you something else that happens here. So, unlike the case, this now is also sorted by value. With forwards, when we took the top 3 by value, remember that that initial team was actually far too cheap, and we wanted to add budget. So we ended up subtracting off a positive points adjustment. Here, the initial team, when I sort by value, is actually too expensive already. However, that's fine because we can just use a negative points adjustment. So if I do this, sort that by the adjusted value instead of the value, then the price drops down to 25.5, and if I subtract it off more, it would go down further, and I'd eventually get a team that's within the budget I want. Of course, for defense, defenders, it's common to use strategies because you only play typically 3 of your 5 defenders. People often use strategies other than just trying to find the 5 that score the most points individually. I often try to find some strategy of rotating defenders. And so one approach that's used is actually to pick 2 defenders that are expensive, that are going to play every game, and then 3 cheap defenders. If we do that, let's say 4.5 million pound cheap defenders, that leaves us with a budget of 24 minus 3 times 4.5, or 10.5. And we can just change these sums so that we're just looking for the top 2 defenders. So we're just trying to figure out which 2 should we spend our 10.5 on in order to get the best expensive players to go along with our 3 cheap ones. And in fact, this minus 50 that I'm at now, that's 10.5, and a little searching around, we'll see there's not really a good option that's that costs 10.5. So this one would be a very reasonable choice, the 2 on the top of the list right now, of Skirtle and O'Shea, to go along with 3 cheap players. and we'll use that 0.5 somewhere else. Well, hopefully this has been useful to you, and hopefully this method is something that you can use to construct your own optimal teams. And thanks for watching.